Okay, so I figured I would make this video going back over the trig for the ones that were not able to be in class this week, and also hopefully so you guys can go back and do some review. So this week in class we went over the basics of trig. So trig's important again because most of your AC formulas involve trigonometry because of that out of phase relationship, which we'll talk about later on down the road. So just to recap, so let's go back through the trig. So those that were not able to be here this week, probably you have read through the PowerPoint, and probably the PowerPoint didn't make a whole lot of sense at that point. So hopefully this will clear things up for us. So what we talked about this week is the right triangle. So in trigonometry, we have our right triangle, and a right triangle consists of a right angle, which is 90 degrees, and then three sides and two angles, which will equal 90 degrees. So a right triangle is 180 degrees total. So if this is 90, angle X and angle Y will end up being 90 degrees added together to give us our 90 plus 90, 180. All right, so we use this because when we develop an out of phase relationship between components and AC, this angle right here will tell us how out of phase we are with our components, our voltages and our currents. Okay, so the triangle has three sides. So I said for now, we're gonna label those sides C, A, and B, but slowly we're gonna start integrating electrical quantities in its place. So this will become Z, this will become R, and this would become X subscript L, which represents electrical quantities. All right, so the triangle has three sides. So one thing stands true is that side C, which is the longest side, is always going to be the hypotenuse. The hypotenuse is always going to be the longest side of the triangle. And with our triangles, that is going to be side C. So once we start getting into the electrical quantities, the hypotenuse becomes totals, okay? So then we have the opposite and the adjacent sides of the triangles. All right, so let me find a good marker here. Okay, so we have the opposite and adjacent sides. So the opposite and adjacent sides are all dependent on which angle you are actually referencing. So therefore, the opposite and the adjacent sides can change depending on which angle that you are actually at. So for example, if you are at angle X, so I call this angle X since it's on my X-axis, looking from angle X, side A would be the opposite side of that angle, and side B would be the adjacent. So essentially, if I was standing in one corner of the room looking straight ahead, then one wall would be my opposite. But if I went to a different corner and looked straight ahead, well, a different wall would be my opposite. So it's the same concept here, okay? So coming from angle Y, side B becomes my opposite, and side A is my adjacent. So the adjacent side is pretty easy to pick out, just like the opposite. The adjacent side is the side that always intersects with the angle that you are referencing. Okay? So, pretty simple. Hypotenuse is the longest side, and then the other two sides are all determined by which angle that you are coming from. Okay? So, with the triangle, as far as figuring out sides, so I will say that this only works if you are solving for one side and you're given two sides already, okay? Or if you get to a point in the triangle where you have figured out two sides, you can figure out the third side using this, okay? So in your notes or in the PowerPoint, this is what we call the Pythagorean Theorem. So the Pythagorean Theorem states that c squared is equal to a squared plus b squared. Okay? So that is c squared equals a squared plus b squared. So that is saying that the hypotenuse squared is going to be equal to the opposite side squared added to the adjacent side squared. Okay? So these are the different versions of that formula. So if you're pretty efficient in algebra, or just slightly efficient in algebra, then you can figure out these different versions. So for instance, c squared equals a squared plus b squared. Well, if I want to solve for a squared, to get that alone, all I do is subtract b squared off from this side. And whatever I do over here, I have to do the same over here, which ends up being a squared is equal to c squared minus b squared. And then the same if I'm solving for b. Okay? Now, I told everyone in class that this is not actually your working formulas because a variable that you're solving for, so c, a, and b, can't be squared. So the actual formulas that you'll be using are these. So if I want to get rid of the squared here, when I get rid of it, I have to do the opposite over here, which means that I'm going to square root it, because square root is the opposite of squared. So that's how I come up with these, which are the actual formulas you'll be using. C is equal to the square root of a squared plus b squared, and a is equal to the square root of c squared minus b squared, and then b is equal to the square root of c squared minus a squared. Okay? So that's really all there is to the Pythagorean theorem. It's one formula derived two different ways. And then, of course, in this format is what we're actually going to be using when we're figuring out the sides. So next on the list is sometimes you may only have one side and an angle. So that's when we're going to have to rely on sine, cosine, and tangent. Okay? So sine is going to be the opposite over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent is the opposite over the adjacent. So your normal functions, just sine, cosine, and tangent, is used when you're using an angle in one side to solve for another side. So for instance, if I gave you one of these angles and one of these sides, you would use one of these three formulas to solve for one of the other two sides. Okay? And there's a couple of different ways that you can remember this. So your book says that if you can remember sine, cosine, and tangent, you can remember Oscar had a heap of apples. And then one of the most widespread is SOHCAHTOA. So it would be SOHCAHTOA. Okay? So that is going to be SOHCAHTOA. So I told the class earlier this week that the easiest way to get this down is honestly just to work a couple. Okay? So the homework that I have assigned, and also a lab sheet, which I will send to the people that were not able to be here this week, pretty much just gives you a couple of word problems and then gives you a chart where you get 2 or 3 missing values and you have to solve for them. So like I said, the easiest way is to just go ahead and work a couple. So we're going to do that right now. Okay? So what we are going to do is set up C, A, and B, angle X, and angle Y. Okay? So we have C, A, B, angle X, and angle Y. And I want you to go ahead and, if you haven't, get a scrap sheet of paper out and work these with me. Draw a couple of triangles. Don't label the sides quite yet as far as opposite and adjacent. Just go ahead and draw one out. Label angle X, angle Y, C, A, and B. So I'll give y'all just a few moments to do that. And I'm actually going to get my calculator. And so take just a few minutes. I'm going to leave it recording so I don't split this into two different videos. So I should be back in about a minute. So if you want to fast forward to get to where we start working it, you can. All right. Okay, so for the first one, I'm going to say that angle X is 18 degrees, and I'm going to say that side C is 25.8. Okay, we worked one just like this, actually this exact one in the lab this week. So let's look at what we have, and I'm going to give you some tips and tricks on how to narrow things down. Which one of these formulas? So first off, I know that I cannot use the Pythagorean Theorem because I only have one side. I need at least two sides to be able to do those formulas. All right, so I know right off that I'm going to have to use one of these three. Well, one of the first things that you can do is you can figure out angle Y. So what did I say earlier? Angle X and angle Y have to equal total 90 degrees. So if 18 degrees is already accounted for, then that means that Y needs to be whatever is left to make that up. So 90 minus 18 is going to give me 72 degrees. Okay? So now what you want to do is you want to pick an angle to work from. You can work from angle X or you can work from angle Y. It really doesn't matter as long as, very important here, you label your sides correctly according to that angle. So for instance, if I say I'm going to work from angle X, then that means that I need to label AB accordingly. So remember, C is always the hypotenuse. Always. That's concrete. So looking from angle X, we know that side A is going to be my opposite, and side B is going to be my adjacent. So I've labeled my sides. So now I'm ready to see which formula I need. All right, so let's say that I want to solve for A first. So looking from angle X, we said that side A is opposite. So that means that I'm going to be solving for the opposite side. So first, decide, am I solving for the opposite side, the adjacent side, the hypotenuse? Which side am I trying to solve for? So side A happens to be my opposite. Then ask yourself, what side am I given? Well, I'm given the hypotenuse. So see the relation here? See, kind of connecting those dots. Solving for the opposite, I'm given the hypotenuse. So that narrows it down to I'm going to be using sine, because sine is opposite in hypotenuse. Okay? So how I would set that up as a formula is I would need to say the sine of angle X, which is 18 degrees, is equal to opposite, which is A, over the hypotenuse, which is 25.8, and that's going to be where I start. So in order to simplify this formula, and I told everyone that as you work more of these, you'll get into grooves. So if my unknown is on top, I'm going to multiply. If my unknown is on the bottom, I'm going to divide. But for now, I'm just assuming that everybody's fresh, or maybe they haven't done trig in a while. So I'm going to take the extra steps. So if this side is a fraction, I need to make this side a fraction. So remember, our rule is that to make this a fraction, all I have to do is put it over 1. And now, to simplify this further, I'm going to do cross multiplication. So, multiplying this way, I have A times 1. A times 1 is A. And then on the other side, I'm going to have the sine of 18 times 25.8. And if I do that, that will give me side A. Okay? So in your calculators, it depends on which calculator you have. In the syllabus, it states that the TI-30XA will work just fine, and it will. If you have the TI-83 and up, that works just fine as well. So depending on which calculator you have is slightly different how you might will key this. If you have the TI-30XA, the smaller calculator, then you will need to punch in the angle first. So you're going to type in 18, then hit the sine button. So that's going to take that 18 degrees and it's going to convert it to a decimal. So you should see that appear as a decimal. Okay? So type in 18, hit sine, and then multiply by 25.8. If you have a fancier calculator, you're going to just type in sine 18, close parentheses, and then you're going to multiply by 25.8. Okay? Sorry about that. So you're going to hit sine 18, close parentheses, and then multiply by 25.8. So if you do that, what do you get? Okay? So I'm going to give everybody just a moment to do that and see what they come up with. Okay? So if you got 7.97, you are correct. Okay? So if you got 7.97, you are correct. So now the last step is if I want to solve for b, well, I have two sides now, so all I have to do is Pythagorean Theorem. So b equals the square root of c squared minus a squared. So that's going to be 25.8 squared minus 7.97 squared. Okay? So everybody take just a moment to do that. So again, difference in calculators. The easiest way to do this, if you have the TI-30XA, you're going to want to key in 25.8 squared minus 7.97 squared, hit equals, and then take the square root. So if you need to back that up and listen again, do that. So that's how you would key it in with the TI-30XA. If you have any other calculator like the 83, 84, or whatever, you can type it in exactly how it looks. Okay? All right, so y'all go ahead and do that and see what you get. Okay, if you got 24.54, you are correct. Okay, and that's all there is to that one. So now we're going to work one more type, and then we will call the video done. Okay, so I'm going to do one more type. So I'm going to say that, what if I have this going on? Okay, all I have is two sides. That's it. I just have two sides. All right, so these actually aren't as bad as they look. They look like they would be harder than the other ones, but actually they're easier. And this gives me a good chance to talk about the difference between sine, cosine, and tangent and their inverse relative, which is inverse sine, inverse cosine, and inverse tan, which would be represented with a -1 out here. So for instance, sine, -1, cosine, -1, and tan, -1, which the -1 in math means inverse. Okay? So let's talk about that for just a second. So first thing off, what we would do is we would go ahead and find B. We go ahead and find B. So if I have C and I have A, I can find B, and I can use Pythagorean Theorem. So B equals the square root of 75 squared minus 55 squared. So that's going to give me side B. Okay, so that's going to give me side B. So I'm going to go ahead and give y'all just a moment to get that. Okay, and if you got 50.99, then you are correct. Okay, 50.99, you are correct. All right, so here comes the difference between sine, cosine, tangent, and inverse sine, inverse cosine, inverse tangent. All right, so sine, cosine, and tangent, your normal functions, are used when you already have a known angle degree, or a degree angle. and you're trying to solve for a side. So essentially, if you think about it, when you key that degree in and then hit sine, what does it do? It converts it to a decimal. Well, the inverse of those are going to take a decimal and it's going to convert it back to an angle. So this is used when you have a known angle and you want to convert it to a decimal to multiply and get a side. This is used to take a decimal and convert it back to an angle. Okay? And you can give this a try. So you can type in 18 degrees and then take the sine of that. It's going to give you a decimal. Okay? We'll keep a record of what that decimal is. Then punch that decimal into your calculator and take the inverse sine of that, and it's going to revert it back to the angle. It'll give you the same answer. Okay? So, once I have found all three sides, it's pretty easy from here. Okay? So, I'm going to pick an angle to solve for. So, let's say I'm going to solve for angle X first. So, looking at angle X, A is the opposite, B is the adjacent, and C is the hypotenuse. Okay? So I can pick any one of the functions that I want. It doesn't matter because I have all three sides. So for instance, let's do tangent. So how I'm going to set that up is I'm going to do tangent, which is opposite over adjacent. So A is my opposite, B is my adjacent. So I'm going to do 55, which is the opposite side, divided by the adjacent, which is 50.99. And that should give you a decimal. And then what function did I just do? Tan. So what I'm going to do is I'm going to take the inverse tan of that. Okay? So I just do the function opposite over adjacent, which I did, and then take the inverse of that. Okay? So everybody do that in their calculator. If you have the TI-30XA, just do your division first. So 55 divided by 50.99, and then take the inverse tangent of that. And you should get 47.17 degrees. If you have the TI-83, I do believe that you can just type in inverse tangent, close parentheses, and then have your division out to the side. Okay? If not, do your division first, hit second tangent, because it is a second function, notice on your calculator, and then plug that previous answer in. Either way, it'll work. Okay? And then to get angle Y, I can just take the easy route and do 90 minus 47.17, which gives me 42.83 degrees. Okay? So really, that's all there is to it. Okay? If you have any questions, please reach out, let me know. This is about the extent of trig that we get into. Really, it only takes about one lesson to get this. I think this video is right at 30 minutes, give or take. So like I said, this for those that were not able to attend this week, and also if you want to go back and refresh on it before the test on the trig. So please let me know if you have any questions. Feel free to shoot me an email. This is actually pretty easy stuff to answer in an email. I can usually guide you in the right direction. If you have any questions with your homework questions, please remember the homework is due by Friday. And remember the new assignment policies. So if it's late, it is 50% of the grade, and then if it's 2 days late, more than 2 days late, then there is no makeup. Okay, so just please remember those policies. We got to be strict. We got to stick to them. So again, if you can't figure it out, please shoot me an email. I check my email pretty regularly, especially while I'm at work in the afternoons and the evenings. I try to check it when I can. Okay, and if not, I'll get back to you the very next morning once I am here. All right, so y'all let me know if you have any questions. And then tomorrow I will have a video up of some AC basic operating principles. Okay? So y'all have a great evening, and I will see you later.